Hello all, in today's session, we are going to learn additional features of ER model, that is entity relationship model. To use entity relationship model in an effective manner, the features are extended for it. And there are three additional features included for this model, namely generalization, specialization, and aggregation. So in this lecture, we are going to discuss about these three concepts. Coming to the additional features of ER model, they were made to the existing entity relational model to make it able to handle the complex applications better. In order to manage the data stored in the database in an effective manner, this features of entity relationship model has been extended to three more, namely generalization, specialization, and aggregation. Now let us see what are they. Coming to generalization, it is a process of extracting common properties from a set of entities and creating a generalized entity from it. Now, what do you mean by this? We have to extract common attributes from the entities, and then we need to create an entity from those entities. Then this will give you a generalization, which is an added feature for an entity relationship model. For example, I'm going to consider two entities. Here you can see student as an entity and faculty as an entity. So for student, which all attributes can be included along with the student fees, we may also include features like student ID, and the attributes are represented using an owl symbol. Every student has got name, so we are considering name as an attribute for the student, age of the student, and we can include address for a student. Also, we may have an attribute called marks of the student. Now, similarly, you need to identify the properties or the attributes associated for this faculty entity. For faculty, we have ID, name of the faculty, address of the faculty, the department to which the faculty belongs to. Salary can also be considered as an attribute for the faculty entity. Now, we are considering that these two are the lower level entities, and you have to identify which among these entities are having the common attributes. Coming to the common attributes for faculty and student, we have name, and the name also matches here. We have address for the student entity and address for the faculty entity. So these are the common attributes which we have found in common. This is the meaning of the first point, which is written for the generalization. What it is? It is a process of extracting common properties from a set of entities and creating a generalized entity from it. We have identified the two entities and found that the name and address are common for these two entities. And then we are going to create one more entity from it, which is known as a person. And this person is having the common attributes, that is address and name. So this is an entity which is having the generalized attributes that are created from the lower level entities, namely faculty and the student. It is a bottom-up approach in which two or more entities can be generalized to a higher level entity, as discussed before, if they are having some attributes in common. So it is said that it is a bottom-up approach, which means you have to start from the bottom and then you need to build an entity, or you have to create an entity from bottom moving towards an upwards direction. And the relationship that exists between these three entities is a relationship. And this is a symbol used for representing the generalization. In specialization, an entity is divided into sub-entities based on its characteristics, and it is a top-down approach where the higher level entity is specialized, or it is divided into two or more lower level entities. So if you see this definition of specialization, which is an exact reverse of the generalization. From generalization, we have created a new entity, which is from the lower level entities, from bottom to upwards direction. whereas specialization is something that an entity is divided into two more entities based on the characteristics or the properties, and hence it is said that it is a top-down approach. Let us take an example and view what a specialization is. Coming to this example, we have employee, which is an entity, and from this employee, we have several other entities we can create from it, as it is a top-down approach. A tester can be an employee and developer is also an employee. For employee, we can identify salary and e-name are the attributes. Along with this, there are several other attributes belongs to the employee, and the same kind of attributes also may added for the developer who is an employee, tester who is also an employee. And we have another attribute. This can be an optional. It defines the test type as an attribute or the property for this particular entity. Now let me take another example and explain you what is specialization. I'm considering account, which is an entity, and for the account, we can identify the attributes as balance and one more attribute as account number. Now from this, we can create two other entities which has a relationship with an account entity. So let the two other entities be current account and savings account. Now, what all attributes you can identify for it? These attributes are common for current as well as savings, namely number and balance. Similarly, for savings account, we have the same attributes, account number and balance. So what is this? This is simply an entity which is divided into some other entities, which is a higher level entity, and it is divided into lower level entities. This is known as a specialization. Relationship between an entity and a relationship which may be required in some scenarios. In those cases, a relationship with its corresponding entities is aggregated into a higher level entity. What do you mean by this? In some of the cases, we find that there may exist some entities. In some cases, we can identify that there exist several entities which may not be able to represent the relationship with the other entities. So in that cases, the relationship with its corresponding entities is aggregated into a higher level entity. That means you can associate a relationship over a relationship, and that is known as an aggregation. It's not that the relationship exists between the two or more entities. A relationship can also be associated with some other relationship, and this kind of representation will be made for an entity relationship diagram only in the cases when the entities are not able to maintain or associate a relationship with some other entities, and that relation can be considered as an aggregation. Let us take a small example for illustrating what an aggregation is. In this example, we can find there are three entities, namely project, employee, and another entity, say machinery. Assume that there is an entity in which we are storing the details of several employees. Now, in this relation, an employee is having a relationship with the project, and the name of the relationship is known as works for. This denotes that an employee is working for a project. An employee can work for a project, or there may exist a number of employees who may work for many number of projects, right? It can be a total or a partial relationship. Now we have another relationship called require as a relationship. Assume that an employee requires some machinery to complete the project. In that case, we require a relationship which connects with the other relationship, and hence with the help of the tools or the machines that is given to the employee, he may be able to complete his project. So assume that Machinery is another entity, and it is having a relationship with the relationship that is existing between the employee and the project. And this kind of representation is known as aggregation. Conceptual design with entity relation model. We have discussed what is a conceptual design, which is one of the phase among the data model. It simply gives you the description about the database, and it includes the detailed information about how the database is to be designed. It does not concentrate on the implementation part of the database. So before we implement or construct the database, we are going to represent it in a pictorial form or in a diagrammatic way. And that model is known as ER model, which is an entity relationship model.